Let's look at the chain rule extended. So sometimes you're going to have to fight your way out of the function. You have more than one function composed with another. Then you just have to keep going until everybody gets differentiated. You start with the outsidest function and work your way in. Let's look at number 39. We have the tangent of the secant of the cosine of t. So we start with our outsidest function first, the derivative of tangent. And I didn't give it a name. I'm going to call it y. So I can label my answer as y primed. So derivative of tangent comes first. Secant squared of secant of cosine of t. That's the outsidest function. Now I look at secant. Derivative of secant is secant times tangent. So secant of inside function stays the same. So I've worked my way into secant. So now I've taken the derivative of tangent, I've taken the derivative of secant, I'm ready to take the derivative of the most inside function, which is cosine. Derivative is negative sine. So everybody gets to be differentiated. Outside to inside. Let's do another one. We have y equals e to the sine of 2x plus sine of e to the 2x. So we have two separate pieces here with a big plus sign between them. That means we'll look at this piece, then we'll look at that piece. So our first piece, e to the sine of 2x. Our outsidest function is e. So that we just write down the function itself. Our next function is the sine of 2x. So derivative of sine is cosine. Inside function stays the same, times the derivative of its inside function, which is 2. I'm going to go to the next row because I write big. My outsidest function here is sine. So derivative of sine is cosine. Inside function stays the same. Now I look at the function e to the 2x. Outside function for that piece is e. You just write it down exactly the way it is. And the inside function, 2x. Easy enough. We're going to go ahead and do all of these together. You'll have plenty of practice on your WebAssigns, and yeah, I have you an extra practice sheet as well. So we'll go ahead and do these together. Number 41, we have f of t is equal to sine squared e to the sine squared of t. That is one ugly looking function. So if you want to, you can rewrite this as sine of e to the sine squared of t, whole darn thing squared, just to remind yourself that the first function, the outsidest function, is squaring stuff. So 2 falls down, subtract 1 from the exponent. The next thing we come to as we force our way inside this ugly function here is sine. The derivative of sine is cosine. Inside function stays the same. So far I've taken care of the squared, I've taken care of the sine. Now I'm ready to look at this inside function here, which is e to the sine squared of t. So e to the sine squared of t, and all of this is multiplied together. I just write too big to get it on one line. Then I need the derivative of sine squared of t. Remember, that means sine of t living inside a set of parentheses, whole darn thing squared. So 2 times the sine of t, subtract 1 from the exponent, times the derivative of that thing's inside function, cosine of t. That one took a lot of work, but you can do it. Don't give up. Everybody gets to be differentiated. Finally, I'm going to go ahead and write this as x plus, open up a set of parentheses, x plus x to the 1/2 to the 1/2 to the 1/2. I don't know which is uglier, all those exponents or all those radicals. Outsidest function first, 1/2 falls down. Inside stays exactly the same. Subtract 1 from the exponent. So I took care of my outsidest function. Times. Now I'm going to look inside the set of parentheses. The derivative of this is 1 plus, now I have this other little piece, 1/2 falls down, times x plus x to the 1/2 power, subtract 1 from the exponent to the minus 1/2 power. But I'm not done, because this one has an inside function. I have to find the derivative of this inside function, which is 1 plus 1/2 of x to the minus 1/2. So we worked hard for that one too. We started out with the outsidest, 1/2 fell down. Then when we looked for the derivative of this inside function, the first piece was just an x. The next piece was another chain rule. 1/2 fell down. 1/2 fell down. We have x plus x to the 1/2 power. Subtract 1 from that exponent, and then we differentiated the pieces inside. Okay. We will do one tangent line, then I'll leave the rest for you to do. And let's see. I'm going to do number 53 because students generally hate the trig functions most of all, so I'll do that one with you. is equal to the sine of the sine of x at the point pi 0. So we got our point, we need our slope. Outside a function is sine. So the derivative of sine is cosine of sine of x times derivative of the inside is cosine of x. So I want to evaluate this thing when x is equal to pi. Now, cosine of sine of pi times the cosine of pi. Well, sine of pi is 0. Cosine of pi is negative 1. Cosine of 0 is 1. Cosine of pi was negative 1. So y minus my y coordinate is equal to slope, and my y coordinate is 0. I wrote down the x coordinate. Y minus 0 is equal to negative 1 times x minus pi. Let's Desmos this bad boy and see what it looks like. Because it's beautiful and it's free. So we have sine of x. So it looks a lot like sine. It's just a little squiggly wave line. And our point is pi 0, lives right there. And let's look at y is equal to negative 1 times x minus pi. Look at that pretty tangent line. Awesome. Okay. I have a worksheet for you, and I'll do a little intro to that. And I will finish doing all of these, and you will know all about the chain rule. Good job.